This is the second part of your discussion in study population and sampling design. Guys, we're talking about determining the sample size. So again, in determining the sample size, you need to be able to determine the desired confidence or alpha level. Oftentimes, we call that alpha level. This is the same as the margin of error that I have mentioned earlier. So class, in the alpha level, you have three: 1%, 5%, and then 10%. Okay? Correct me, ha? So class, that's 0.01, 0.05, and 0.10. If it's 0.5, that's 50%. That's too much already for the margin of error. So again, we're only playing with 1%, 5%, and then 10%. Oftentimes referred to as your alpha level. It is your alpha level. Now, there are different formula that could be used in the computation of your sample size. Okay? Now, in this formula, we can see that the sample could be determined by doing the nz squared minus p times the quantity of 1 minus p all over ne squared plus z squared p times 1 minus p. Okay, sir, there's a lot of things to be remembered. Okay, you can memorize those. In other books, you would write it as nz squared pq. I mean nz squared minus pq all over ne squared plus c squared pq. And then q is just simply 1 minus p. Okay, now what is z? Z is the confidence level value. The confidence level value is actually a constant. No? It's a constant. That constant is 2.58 if we're talking about 1% margin of error. It's 1.96 if we're talking about 5% margin of error. It's 1.65 if we're talking about 10% margin of error. And so again, those are the possible values of Z. And then P is the largest proportion. It's the largest possible proportion, which is equals to 0.50. So in other words, for example, if I'm conducting a research and then I'm not sure if what proportion of the population is my study respondents would be, I would set the P and the Q at 0.5. But if I'm sure that my study population will be at around 20% of the population, I would write P as 0.2. Okay? Arbitrarily, okay, if we are not sure if what proportion is that, we write it as 0.5. Okay, take note of that. We write it as 0.5. Now, please do not be confused with the symbols that we are using. Okay, the small letter n is the one that corresponds to your sample size. Okay, let's correct that. It should be the small letter n that corresponds to your sample size. So the small n here, the sample size could be determined by computing for nz squared. That's the big N, meaning that refers to the study population. Next, the E is the sampling error. So if 99%, that's 0.01, 0.05, and 0.10. N is the population size, and then small n is the sample size, as I have mentioned earlier. Next, the sampling design. So there are a lot of sampling design. But prior to that, no, I would like to touch another common formula. The common formula that I will be talking about is the one that previously referred to as your Slow-Vin's formula. The guys, other statisticians would say that the Slow-Vin's formula is actually a derivative of the formula that I have shown you earlier. Okay, so the Slow-Vin's formula would state that small n, or the sample size, is equal to, let me recall, that is n divided by 1 plus ne squared. Again, that is small n is equal to n, big N, over 1 plus ne squared. Okay? Formula applied well, I think the maximum number of participants that you can get regardless of the sample population is 400. In other words, if I would have 1,000 and even if I would have 3,000 respondents, the sample size would narrow down at around 400. Okay? So that's one formula that you can use. However, if you will be using this formula, just make sure that you are having proper citations. And that is not your Tito Sloven already. Okay? So you try to find authors that reflect this formula. Next, the sampling design. There are two main types of sampling designs. Okay, that's probability sampling and then non-probability sampling. You write on the side that when I say probability sampling, this talks about random sampling technique. When I talk about non-probability sampling, it talks about non-random sampling technique. In other words, class, probability sampling would give you equal chances to be part of the study sample. Again, probability sampling would give you equal chances to be part of the study sample, whereas the non-probability sampling would not give you equal chances to be part of the sample. And now, let's expound on that or elaborate on that. Okay? Probability. It says equal probability that you can be included in the sample. The keyword there is equal. Okay, everybody among us would have equal chances to be included as part of the study population. Okay, or study sample, I mean. Okay, there is fair sample selection and that could allow for estimation. Next, non-probability. There is no way to estimate the probability that each unit has a chance of being included. But why are we doing non-probability sampling? Your non-probability sampling is convenient and economical. And then, guys, if you will ask me again if which is better, probability or non-probability sampling, the answer would still depend on the type of research that you are embarking. If I am talking about quantitative research, and then you would want a survey research that would be applicable to a population, then you need to embark on random sampling techniques. If you're talking about researchers are usually on non-probability sampling techniques. Okay, so it would depend on the type of research that you would be embarking on, and also depend on the study population and sample size. Now, what is the design most appropriate for your research? If you will be embarking on, let's say, for example, the level of knowledge of student nurses in an online class, random sampling would be appropriate. If, let's say, for example, I would want to study the lived experiences of student nurses who are employed in this time of pandemic, non-probability sampling would be accurate, or non-probability sampling would be appropriate. If I would, for example, would want to study among victims of abuse, okay, then I could employ purposive sampling, which is a component of non-probability sampling, choosing from only the abuse patients or abuse victims. No, I need to follow a specific criteria from which I could get, okay, from which I could get the sample size. Okay, so again, it would depend on the type of research that you are embarking on. Next, so there are different probability sampling designs. In probability sampling, you will encounter several. There are 5 most common. Okay, the first one is simple random sampling. It's perhaps the most basic available to us. Okay, basic. It's the best known probability sampling design. Siya yata yung pinakasikat. And then it gives us equal chances of being included in the sample. Okay, of course, all of the probability sampling design would give us equal chances of being included in the sample. Now, look at the pictures on the slide, or the side, I mean. The pictures on the side would show us the examples of simple random sampling. You have the table of random numbers, and then you have the fishbowl method. Now, how do we use the table of random numbers? For example, I computed my sample size of 100 out of 300 per population. I need 100. I will close my eyes and then I'll have a pin, or maybe I'll have a ball pen or a pen with me, and then I'll point the pen on the table of random numbers. For example, the table of random numbers or my pen landed here. I could say, okay, I'll start with 9. Next, meaning I will get participant number 9. Next, participant number 9 still, meaning that's not applicable. Next, let's go to participant number 1. Let's go to participant 0. Or if you're talking about 2-digit listing, let's say, for example, your list is up to 100. Or let's say your list is up to 500. Okay? The random start was here, 424. Okay. Next participant, 222. Next participant, 349. Next participant, 676. Oops, there's no 676. So I will proceed to 429. There's no 519. There's no 631. So I will continue to do that until I am able to complete my sample size. Okay? Now, who is generating the table of random numbers? In the past, it may have been generated by people who would love to write numbers randomly. But at present, this could already be computer generated. At present, these are already computer generated. Okay? Now, fishbowl. The usual that we use maybe at school, and then the usual that we do in our dealings. Okay, you list all the names, put it inside a fishbowl, or maybe a Tupperware for that matter, and then pick randomly. Okay? Pick randomly. Okay, take note of that. You pick randomly. So let's say, oh, I pick the name of participant A. Okay, she's included. Then participant D, she's included. Participant F, she's included. Okay, so that's how you treat your simple random sampling. Could be table of random numbers. It could be your fishbowl sampling. Next, you have your systematic sampling. So your systematic sampling allows for the establishment of what we refer to as your sampling interval. The word there is sampling interval. Okay? Now, what do I mean by sampling interval? That's the KTH value. We refer to that as the kth value. That's your systematic sampling. How do we determine the value of K? Your value of K is basically the population size divided by the sample size. Now, let's take this as an example. For example, if my study population is 500, and then I need to have a sample size of 100, just as an example, I would know that the K value is equal to 500 divided by 100. 500 divided by 100 would give us a fifth. Meaning, if I have the listing of all the participants, let's say from 1 to 500, I would have a random start. Let's say my random start is 3 because my pen pointed at 3. And then I will add 5. I will get the 8th participant. I will get the 13th participant. I will get the 18th participant. I will get the 23rd participant, 28, 33, 38, until I am able to complete all the 100 samples that I need. Okay, it's referred to as systematic sampling because there is a number wherein you would take every K in the list. Okay, every KTH on the list would be taken as the sample. That's why it's referred to as systematic sampling. Next, you have your stratified sampling. Your stratified sampling is best used if we're talking about heterogeneous population. In other words, these are population members who would have differences between one another. These are population members who would vary from one another. Okay, example, a very good example is the student nurses. So level 1 is different from level 2, level 3, and level 4. So when I talk about strata, as I've mentioned earlier, those are groupings which are mutually exclusive. Okay, so the purpose of your stratified sampling is to ensure that there will be a representation, there will be adequate representation from each of the components of the sample. Okay, to ensure that there will be adequate representation from each of the component of the sample. Now, it could be stratified simple random sampling, there is stratified systematic sampling, stratified proportion sampling for that. So let's take, for example, that we have 4 groups. No? So level 1, level 2, level 3, and level 4. The total of these levels, of all of these levels, is 500. Let's say we ask the office and then we know that there are 300 first-year students, there are 100 second-year students, and there are only 50 third-year and there are 50 fourth-year respondents. When we computed, for example, using a certain formula, we found out that we need 200 participants. Okay, we need 200 sample sizes. So what are we going to do? We need first to determine the percentage. Okay, we need to determine the percentage. Now, what is the percentage? Let's have 300 divided by 500. That would give you 0.6. Okay, that would give you 0.6. Let me see. And then that times by 100, that will give you 60%. So meaning this is 60%. If you will do the same process, this will give you 20%. This will give you 10%, 10%. If you would look at the total, that should sum up to 100%. Okay, that's the total of 100%. Now, if you would look at this, okay, what do we mean by that, no? Na naka 60, 20, 10, 10. We need to get the same proportion for our participants or sample size. Okay, take note, this is your big N here, and then your goal here is your small n or your sample size. From that, 200 yung kailangan natin, di ba? So 60% of 200, meaning I will get 120 here. 20% of 200, I will get 40 here. I will get 20 from this population and 20 from this group of population. If you would look at it, since there are 300 level 1 students, they would have more participants in our research. Since there are only 50 level 3 and level 4 students, they would have lesser participants in our research. Okay? If you would go back to the definition of stratified random sampling, it tells you that there should be adequate and proportionate representation for each of the subgroups. Okay, for each of the subgroups. That's the purpose of your stratified random sampling. Okay, take note of that. Now, cluster sampling. When I say cluster sampling, it's a random selection of groups. Okay, random selection of groups and not really individuals as samples. And cluster could refer to any group with shared similar characteristics important in the study. So this could be area sampling or geographical consideration. What do I mean by that? For example, I am studying in, let's pick for example, uh, a certain municipality again with several barangays. And then some of the barangays are on the islands. Okay? And then in an island, there are about several barangays. Let's say, for example, in this island here, there are 3 barangays. Okay, 3 divisions, 1, 2, and 3. In this area here, there are 2 barangays. In this area here, there are also 3 barangays. And in this area, let's say, for example, that there are 1, 2, 3, 5 barangays. When I talk about cluster sampling, I would want to make sure that each of the island would be represented. Okay? But then I do not need to choose from the entire island. I would say, for example, from Island A, randomly, I pick Barangay 1 from Island A. And all of the residents in Barangay 1, okay, in Barangay 1 of Island A will already be my participants. Okay? For example, if this is Island B, Island C, and Island D, okay, if I would pick randomly barangay in Island B, and then I pick, for example, Barangay 3 in Island B, all of them will be my participants. That's the cluster that we are talking about. Okay, another barangay here, another barangay here. In other words, we cluster them, and by cluster, we choose if who will be the participants. So take note that the cluster is randomly chosen. If the cluster is not randomly chosen, it defeats the purpose. Okay, it's not anymore a random sampling technique. Next, multi-stage. As the term implies, it has several stages. Okay, population units are grouped and arranged into hierarchical order or level, and sampling is done successively, and then sample regions and provinces are being taken. We usually use your multi-stage sampling if we are talking about studies conducted in the national level. So again, when I talk about multi-stage, usually it's national level. So what do we do? No? What do we do in a multi-stage sampling? In multi-stage sampling, it's like this. If I'll be conducting a study in the entire Philippines, I'll choose random provinces in the Philippines. From the random provinces that I have chosen, I will collect or I will randomly choose municipalities. From the municipalities that I have chosen, I will randomly choose the barangays. That's why it's referred to as multi-stage sampling. Okay, and then all the residents of that barangay will be considered part of my research. It's multi-stage since we have different levels. Okay, as I have mentioned, province, from each province, a municipality, from each of the municipality, the barangay, and from the barangay, maybe the specific households that you would want to involve. That's why it's referred to as multi-stage sampling technique. So, what are the advantages? No? Your probability sampling is said to be less biased. You have equal chance to be selected. That's very good. But the disadvantage is that it could be time consuming. It could be expensive. It could also be inconvenient on the part of the researcher. Inconvenient, but in such a way that you need to have a list of everybody. You need to randomly choose from the list that is given to you. Next, non-probability sampling designs. So there's also a lot under non-probability. 1, purposive sampling. In purposive sampling, your basis is good judgment and appropriate strategy. Again, your basis is good judgment and appropriate strategy. What do we mean by good judgment and appropriate strategy? You need to choose participants that are able to describe your study population. You need to be able to choose participants that will be able to give you the experiences that you need. okay, or the enrichedness of the experiences that you will be needing for that research. Okay, that's the purpose of your purposive sampling. So plus in purposive sampling, you also have your inclusion criteria. Okay, one main characteristic of purposive sampling is inclusion criteria. Although in some of the random sampling designs, inclusion criteria is also utilized. But the inclusion criteria is more specific, it's more rigorous if we are talking about your purposive sampling. Okay? Next, you have your convenience sampling. When I say convenience sampling, I would stand, for example, in the Freedom Grandstand, and then whoever passes by, I will give them my questionnaire. That's convenience sampling. That's why it said here, whoever is available. That would constitute the sample and continue doing so until the predetermined sample size is reached. For example, I would just say, oh, I need 100. Okay, and then I would just stand in the grandstand, and then whoever passes by will be my participant. By the time I already gathered 100, I will go home and I'm done with my data gathering procedure. That's what you refer to as convenience sampling. Next, you have the quota sampling. It's about the equivalent of stratified sampling under the probability sampling, and the selection of subjects would constitute the sample in each stratum is done in a non-random manner. Okay? In other words, for example, I want to study level 1. Okay, I want 50 from level 1. Okay, I'll just choose those 50 that I know. Level 2, I will choose the first 50 who would enter the gate of our college. That's the level 2 student that I will be choosing. In other words, there is non-randomness. There is unequal representation. There is unequal chances of being getting or being chosen as your respondent for the study. Okay, unequal chances. That's why it's referred to as quota sampling. Next, you have your snowball sampling. In snowball sampling, there's no available list of population units to work on. It requires identification of few people who meet the requisite characteristic and then important to the study. This is best actually, guys, for example, gays. Okay, we are not giving any judgment to the gays here, ha. But just as an example, okay, for example, I want to conduct study among gays, no, because I'm interested of their behavior, or maybe I'm interested on what they know about a certain social issue. So the best way for me to do it is to approach a friend who is gay, okay, who I know to be gay, and then ask that friend, hey, I'm still doing interview. Do you have other participants that you could refer? Okay, that's why it's referred to as snowball sampling, because if you have been into first world countries, if you have been into countries with winter, you would notice that once the snowball is rolling down the hill, okay, the snowball gets bigger and bigger and bigger. So it's referred to as snowball sampling because from one participant, you will be asking if who are the other qualified participants. Okay, that's referred to as your snowball sampling. Okay, that's your snowball sampling. Next, you have the advantages and disadvantages. So you have convenient. Okay, convenient, it's easy to produce anytime. It's less spent for selection of the respondents. It's it's also economical. It's less expensive, no fixed budget required. However, the disadvantages is that it will be biased. Imagine me standing there at the grandstand and then just distributing the questionnaire. I will not be able to get representation from other parts of the population, but only those who are passing by the grandstand, which is not actually an ideal situation. Next, there is no estimation of precise elements of the population that will be included in the sample, and then there's no equal chances given to everybody. In other words, if I will be using non-probability sampling, I could not say that the results of my study will be applicable to the population. For example, I did non-probability sampling of the student nurses who would come in first inside the gate. I could not see I could not say, that the results will be applicable to all of my student nurses. Okay? That's the one disadvantage or a major disadvantage of your purposive sampling. Now, theoretical sampling. Your theoretical sampling is on the qualitative side already. It is an approach used for grounded theory studies. Its aim is to advance the development of selective theory, which would seek to discover the categories and their properties. And the goal of the researcher or theoretical sampling is not the same as with the probability sampling nor the representativeness. It is a technique of data triangulation using independent pieces of information. Now, to discuss that, when I say theoretical sampling, I would look into the data that I have gathered, into the words that I have gathered. I will try to look into it if the words and the interview that I have gathered could already explain the phenomenon. For example, I'm interested about the post-op experience of children who had gastric surgery. Okay, and then I've noticed that the children would have anxiety. So, are all the interviews already able to explain why is this child having anxiety? What are the factors that could have possibly led to anxiety? What are the factors that could possibly decrease the anxiety? Is that already adequately explained in this procedure? Okay, or is that already adequately explained by the words during the interviews that I have done? That's what you referred to as theoretical sampling. And you do not stop doing the interview until you are able already to get a very rich description of the phenomenon that you are trying to explore. Okay, that's your theoretical sampling. Now, you have the term universe. Universe, totality of elements, okay, to which the research finding may apply. Another literature, it's also the target population. And then people or objects from which the researcher would intend to collect data and generalize the findings of the study. Thus, the study universe. Then you have elements. Elements are basically entities to make up the sample. Then sampling bias. Your sampling bias is influenced by external factors in such a way that the data no longer represents the entire population. Okay, in the same way, sa kanina sa example ko, if you will be pulling out only respondents from the center of the barangay and not from the mountainous provinces, you're having a sampling bias. You are not getting the information from other parts of the locality. You're not getting information from other parts of the community. Okay, so you will have a sampling bias. Next, what are the steps in sampling? So first, identify the target population. That's your universe. Then identify the respondent population. After that, you need to specify inclusion-exclusion criteria. Then specify the sampling design. Will it be probability, non-probability? And then recruit the study subjects. Okay, those are the steps in your sampling procedure. Now, inclusion criteria. I mentioned earlier that your inclusion criteria is needed for us to ensure that our respondents are properly described. So an inclusion criteria is a guideline that we choose to fit subjects with a predetermined set of characteristics. Okay, guideline for predetermined set of characteristics. Example, demographic, geographic, and temporal criteria as appropriate. So let's say, for example, that in a study, I would want, for example, among married women of reproductive age, okay, or let's say for example women of reproductive age, then I need to specify the following are the inclusion criteria. Should be a woman age 15 to 40 because that's for me the reproductive age according to my reference. And then it needs to be the woman should have been residing in the barangay, let's say for example for 5 years, and then he should have given birth to 2 children or the like. Okay, so you should be able to discuss that. Excuse me. Now, exclusion criteria, it is the characteristic that would exclude the potential subjects for the study. Those are people who are not suitable for the study, even if they would meet the inclusion criteria. And researchers must be cautious in the sample selection process in order to eliminate or control the extraneous variables. So what do I mean by that? No? For example, in the study that I have conducted, which is about quality of life among children with epilepsy, one of my exclusion criteria is that I did not include those children with comorbidities. In other words, if this child is feeling something else other than epilepsy, let's say for example the child has epilepsy and at the same time diabetes, okay, because there is juvenile diabetes, right, among children. And then for example, if the child has epilepsy and then another problem such as mental retardation, I am not including them on my study because it might appear, no, it might appear that these children may have very low quality of life, but that is not because of epilepsy, but because of their other conditions. So these are considered to be extraneous variables. In other words, when I say extraneous variables, sometimes it's beyond the control of the researcher. It is not what the researcher is interested of, but it affects the study. Okay, it affects the results of the study. Next, you have the sampling and statistical analysis. So class, if you're doing an inferential statistics, okay, if you're having sampling pala, if you're having a sample size from a certain population, you need to do inferential statistics, which means you need to test for the level of significance. You need to test whether the statistical result is significant or not before you could conclude that there is indeed a relationship between variable A and variable B. Okay? So again, inferential statistics is applicable if you have had sampling design. However, if you have had complete enumeration, meaning, for example, if my study is level 4 student nurses in Iloilo, and then I took all of the level 4 students for my study, okay, you don't need to have your inferential statistics. Okay, you just need to have your descriptive statistics for your complete enumeration. Okay, because in complete enumeration, we already had the study for the entire group. We do not want to check anymore if it is indeed applicable or not, because surely it is. Okay, so what we would want to know is that if you are having complete enumeration, no need for you to have the inferential statistics. Just have the descriptive statistics component. Okay, that's important. Next. So how to state this in my study? So since we're talking about sampling, you try to view the lecture on making of the quantitative proposal, okay, to try to give you an example as to how you'll be stating this in your study. And that will be all for your discussion on sampling and population. Do you have any questions so far?